So in this video, I want to show you some textbooks on what I believe are the main three categories in differential equations. But I found these books down here about the first category. I have an example here, Elementary Differential Equations. This is by Reisner, Martin Reisner. Let me show you here the nature and the origin of differential equations. So there's a ton of examples down here, physical examples and problems. So you have here an example about the linear motion with variable mass, one-dimensional steady flow of heat, electrical networks down here, the differential equation of first order down here. Of course, some geometrical considerations, the method of separation of variables down here, the concept of an exact differential equation. It's a complete textbook, actually, second order differential equations, a thorough treatment, the method of undetermined coefficients. Let me zoom back out there. Method of undetermined coefficients, method of variation of the parameters down here, an example, the Bessel's differential equation, one more additional solution down here, and then they move on to higher order differential equations, actually in chapter number 4. A few, examples about partial differential equations. Actually, it's a thorough treatment of some PDEs down here. There's plenty of nice examples and exercises as well. Systems of first order differential equations. This is the typical stuff you would expect to come across in a, say, second year engineering plan. Here's yet one more textbook, an excellent textbook by Coddington, actually. This is super popular as well. An introduction to ordinary differential equations. And we're going to scroll through the textbook quickly. Complex numbers down here, complex series. Chapter number 1, linear equations of the first order. Chapter number 2, linear equations with constant coefficients. I believe they move on to, solving a second order differential equation. So higher order differential equations would come later in chapter number 2. And then linear equations with a variable coefficients. Existence and uniqueness, super nice topic actually. Chapter number 6, existence and uniqueness of solutions to systems and nth order equations. So this is the book by Coddington. Likewise, we have a beautiful textbook. So Simmons and Krantz, differential equations, theory, technique, and practice. It's of a more applied nature, actually. It contains tons of historical references. You have the chance to check it out, please do, because it's interesting. And the last book is the one we discussed the other day, Introduction to Differential Equations with Applications, actually. So this is the first category of textbooks. A different treatment, if you will. It's related to the theory of calculus on Banach spaces, actually. Okay, so it's geared toward that direction. It's a beautiful, beautiful book in that direction, actually. It's an excellent textbook. So in between these two categories, there's a subcategory of textbooks, of which this is a good example. The book by Ince, I don't know how to pronounce that name, E.L. Ince. So I'm not sure what category this book would belong in, but it's certainly an excellent choice. And it's an excellent textbook, actually. It's very complete, but hey, it's not easy to read it, okay? So if you are trying to get into differential equations as a first approach, right? If you're trying to learn differential equations, don't try this book because it's complicated. Tons of gamma functions here, a little bit about complex analysis as well. There's a third category of books on differential equations, of which we have a few examples down here. This category is what I believe is commonly known as the geometrical theory of differential equations. okay? So I have here the book by Hale. It's an excellent, beautiful textbook, actually. I have the book by Arnold, Ordinary Differential Equations, in English and in French, actually. So by the Springer, and then by, you know, that Russian edition. But the textbook is just the same. Let me show you here the book by Hale, because it's a super, super nice textbook. So the contents here. In chapter 0, linear transformations, and then fixed point theorems. Then chapter number 1, some general properties of differential equations, the problem on existence of differential equations, continuation of solutions. Very nice topic. Uniqueness and continuity properties, dependence and stability, differential inequalities. And then in chapter number 2 here, you move on to the case of two-dimensional systems. So Poincaré-Bendixson is actually, it's a criterion for the existence of what we call limit cycles, okay? So a limit cycle actually is a closed orbit. It's a compact orbit of a certain differential equations, right? So it's like a cycle, actually, all right? The loop, if you will. Differential equations on a torus. Number 3, linearization theory. Linear systems with constant coefficients, linear periodic systems, Hale's equations, perturbations of non-critical linear systems in chapter number 4. Chapter number 5, simple oscillation phenomena and the method of averaging, and so on. All right. Integral manifolds of equations with small parameter here, periodic systems with a small parameter, and the method of Lyapunov as well. So as you can see, this book is geared toward the analysis of phase portraits in the smooth category, okay? So these 2 books down here, I say 2 because this is the same book actually by Arnold. They move along the category of smooth systems. But then there's an analytic category of dynamical systems or differential equations. So the first book that I wanted to show you is the Nonlinear Stokes Phenomena by Ilyashenko. He's a Russian mathematician. I've been to a couple of his, conferences in Canada, actually, in the States, and he is basically the one who came up with this Stokes phenomena. He coined the term Stokes phenomena, pretty much. And one of his students is Sergei Yakovenko. Sergei Yakovenko is a mathematician, and he's in Israel. He works in Israel. He's an excellent mathematician. I know him as well. They wrote actually both this textbook on lectures on analytic differential equations. So the main difference with the first 2 books down here, right? It's the same topic, okay? Geometric theory of differential equations. In these books by Arnold and Hale, they treat the case of C-infinity systems of equations. Whereas these 2 textbooks treat the case of analytic differential equations. And things change radically. Okay, the case of differential equations in the analytic world is totally different from the real case, actually, the smooth case. Hopefully I'll have the time to explain to you about, the topic, the geometric theory of differential equations, because I work on this topic. I have published a few articles about that, and hopefully we'll have the chance to discuss about that in a forthcoming video. Hope you like the video. Thank you so much, and see you in the next one.